Our task is to write the truth table of the logical statement if P then Q, if and only if, not P then not Q. It's a little bit complicated to read, but we know and we understand that the main operation here is the biconditional statement, if and only if, represented by double-headed arrow. But we have here, for both sides, also combinations of different logical statements. So in order for us to write the truth table, we really need to examine them carefully. Let's start with identifying the number of rows needed for our truth table. Since we have here P and Q statements only, we can have this formula 2 to the power of n, n meaning for P and Q's we have 2 squared, which would give us 4 rows. So our truth table would only be 4 rows. Let's start with coming up with a column for P and Q. So we have here 4 rows for each of the column for both P and Q statements. 1, 2, 3, or let's do it again. 3 and 4. That is for both the column for our P statement and our Q. The header is not actually part of those 4 rows. So we need to start here with by placing the truth value for our P and Q. We have here true, true, false, and false for our P statement. For our Q, we'll have here true, false, true, and then false. So we can see that the pairs for P and Q are actually different from one another. Let's start with the first logical statement of the entire task here. Let's have here if P, then Q. Let's add the column for that and identify the truth value for the statements. Since this is a conditional statement, we need to anchor it on the truth table for our conditional statements as well. We know that for a conditional statement, we just need both statements P and Q to have the same truth value for it to be true. That's for a conditional statement. So that means our first row, true and true, is true, and the last row of false and false is also true. For a conditional statement, if our conclusion, the Q, is actually true, talking about the third row, regardless of whether our P statement or the hypothesis is false, automatically our conditional statement is also true. The only false situation for conditional statements is that our conclusion is false. So we have here false, provided that our hypothesis is actually true. Okay, that is for if P then Q statements. Now, for the second part of our biconditional statement, it's also an if then statement, but we are not using P and Q. We are using the negation of P and Q. Hence, let us add here respective columns for that. Let's have here for our not P, a column here, and of course for our not Q, let's also have another column before we subject them into a conditional statement. We know that negation assumes the opposite truth value for our P and Q statements respectively. We have here these 2 columns for P and Q, so simply reverse the truth values. So for our P, you have here F, F, T, and T. For our Q, F, take note of that, T, F, and then T. Okay? So now that we have this, we are going to use these 2 to come up with our truth table for the not P, then not Q. This is still conditional, but this time we'll be using the not P or the negation of P and the negation of Q respectively. Okay, take note again for conditional statements. If both statements are true, or we have the same truth value, automatically our conditional statement is true. I'm talking about here false and false, so that is actually true. And is true and true, this is also true. Earlier, we made the conditional statement for if false then true is true. That is the same here. But when we talk about if true then false, it's actually false. So we have here false statement. This is now for our right hand side statement. Now, using this here in this column, we can now come up with our final column here for our truth table for our generalized statement or the original logical statement identified here. If P, then Q, if and only if. If not P, then not. Sorry, let me do it again. Let me extend the table here because this is not readable. So we have here if P, then Q, if and only if not P, then not Q. All right, so this would be the final table here. It may seem a little bit complicated, but since we already have these two forms here or two columns, considering the correct operations we did earlier, we can now use them. And the main operation is a biconditional statement. Now, for a biconditional statement, hear this. The statement is true if both statements have the same truth value. So, statements talking about here and here. So, let's talk about this one here. We have true and true. So, they are of the same truth value. Automatically, this is also true. That's a biconditional statement. Next, false, true. They are not of the same truth value. Automatically, this is actually false. Next column, true and false. Similarly, that's false. And finally, for the last row, true, true. So our final here is also true. This is now the truth table for the logical statement. If P, then Q, if and only if not P, then not Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.